yet?
No. She's mean though. No.
I think you would have to be to survive.
No, she's not. And 2 people now, for 2 days in a row, have witnessed us getting out of the car and me yelling at her.
Me.
So, it's Jake, and then today it was Natalie.
Okay. So let's take a look at proofs where we're trying to prove that lines are parallel. This is going to be a little bit different than the proofs that we did before, where we were given that all the lines were parallel and you were trying to prove something else. Okay, so I'm giving you one here where I've labeled every single angle in the picture, and it gives you lots and lots and lots of choices as to what to do.
If there are more choices, it's just harder. It's what
Yeah.
you do in numbers. It's so unnecessary.
All right, so let's do this as a flowchart proof just for fun. If you want to do it as a 2-column, that's okay. We've got that Q is parallel to R is given. And we're also given that angle 6 is congruent to angle 11.
Wait, is this just like what we've done?
No, I just got finished explaining how it's not quite what we've done, because here we're trying to prove that some lines are parallel.
Okay.
So we're given that Q is parallel to R, and that angle 6 is congruent to angle 11. Our goal would be to get to the place where we know something that will allow us to prove that A and B are parallel. And it should involve either angle 6 or angle 11. So let's take a look here. What could we know about angle 6 that would let us know that A and B are parallel to one another?
6 and 8 are congruent?
Right. If we knew that 6 and 8 were congruent, that would be enough to conclude that these two lines are parallel. Good. There are 2 other things that we could do.
Couldn't there be like
6 and 3?
6 and 3. If 6 and 3 were congruent, then A and B would indeed be parallel. There's one other thing that we could do with angle 6. What's another thing we could do with angle 6 that would let us know that A and B have to be parallel?
6 and 9 are supplementary? Is that 9 or is that a 7?
That's a 7.
Okay. Oh shoot.
6 and 9 would be congruent.
Yeah, for 6 and 9, if we knew that they were supplementary, that would be same side interior angles that are 6 and 7. Did I say 9 now? Sorry. 6 and 7, if those were supplementary, then we would know that A and B were parallel. Okay? Likewise, there are several things we could do with angle 11. What things could we do with angle 11 that would let us know that A and B are parallel?
11 are supplementary.
11 and which, Jackson?
10 are
Yeah.
supplementary.
11 and 10 are supplementary. That would work.
11 and 9 are congruent.
11 and 9 are congruent. Yep, that would work. Are,
No, you're right.
right, 11 and 14 are congruent. Okay? So there are 6 different ways that we could eventually do this. Okay? Now, from my perspective, partly because it's less writing, if I don't have to do supplementary, I won't do supplementary. Okay? I'd rather prove things congruent. It's a little bit shorter. So if I want to, let's say I wanted eventually to get that angle 6 is congruent to angle 8. Well, I can't start off with that because I don't know A and B are parallel.
Didn't you do 6 and 3? Oh, wait.
No, because I don't know A and B are parallel. But I do know that these 2 lines are parallel, right?
Yeah.
And I know that 6 and 11 are congruent to each other. Could I prove that 11 is congruent to 8?
Yeah, because...
And then that would give me 6 is congruent to 11, and 11 is congruent to 8. And then we could do 6 and 8 are congruent by the transitive property.
Would we have to say,
Wait, hang on, one at a time. What?
would we have to say transitive twice, or like
Well, let's take a look. So if we start off with Q parallel to R, if Q and R are parallel, I could say that angle 11 is congruent to angle 8. How do we know that?
They're all
Alternate interior angles theorem.
Right, the alternate interior angles theorem.
So in turn, 6 and 8 are going to be congruent because 11 and 6 are congruent.
Okay, so bringing these two together, we could say, what was it again?
6 and 8, angle 6 and angle 8 are congruent because of the transitive property.
Yeah, exactly right, because of the transitive property. And if 6 and 8 are congruent, then what do we know?
A and B are
A and B are parallel, which is where we wanted to end up.
How would we explain that?
That's a good question. We're basing it on the fact that 6 and 8 are congruent, right? What kind of angles are 6 and 8?
The corresponding angle postulate.
So, but this is the corresponding angle postulate says if the lines are parallel, then we can conclude that the corresponding angles,
We need the converse. Of
we need the converse, exactly right. This is the converse of the corresponding angles postulate.
Will we ever have to do like a biconditional or a
Biconditionals are for definitions.
Do I have to do anything other than converse?
No.
Negate. What's the name of the negated one? Not.
inverse.
Oops.
It's the inverse. Those are helpful if you're trying to prove that something isn't true. The inverse and the contrapositive are both very helpful for that, but we just don't do much of that. Actually, we don't do any of that. Okay? Any questions about this one? Okay. Let's move on. I gave tons of room for these. Sort of a similar diagram, and similar, you have lots of latitude with how you do this one. I'll do this one as a 2-column, just to be different than the last one. So we'll have our statements and our reasons. So we have angle 3 and angle 10 are supplementary. And that S is parallel to T.
Do we always have to put if there are more than one like givens?
Right, more than one piece of information in the given.
Do you want us to always put it on the first step?
I do. Some people split it up, especially if they're going to, if they're only using one part at first and then they're going to use another part later on, they'll write it later on, and that's fine. So all this is given. Now, when you're given that some angles are supplementary, you're almost always going to have to prove that another set of angles is supplementary in order to get what it is that you want. Right? We want to prove that Q and R are parallel. So what angle could, for example, 10, since we've already talked about 10, be supplementary to that would help us know that Q and R are parallel?
7.
Nope, not 7.
Wait, no, my bad.
6.
Wrong one.
We're trying to prove, remember we want to go across lines to prove them parallel. If 6 and 10 were supplementary, then we would know that Q and R are parallel.
Why couldn't it be 5 and 10?
Why couldn't it be 5 and 10? 5 and 10 are alternate interior angles. They would need to be congruent. Right? My question was, what could I say that 10 was supplementary to that would help me know that Q and R are parallel?
Why does it have to be supplementary?
Because we started with something supplementary,
So just keep on going with that?
we're going to keep going with it, yeah.
Okay.
What could I do with 3? What could I say that 3 was supplementary to? This is a little bit of a stretch for you.
7. Oh,
16.
Well, 3 and 7 are always going to be supplementary no matter what.
16.
Not 16. 3 and 16 are alternate exteriors. They should be congruent.
15.
15. What kind of angles are 3 and 15?
Same side exterior angle?
Same side exterior. So you're welcome to use same side exterior angles. We haven't formally talked about them, but we've talked around them a whole bunch. Okay? But I'll stick with 10 and 6. So I want to eventually, this is kind of my plan, I want to get the 10 and 6 are supplementary. Well, right now I've got 10 and 3 are supplementary. So I don't want the 3, I want the 6. Can I just replace it because I feel like it?
You could show that 6 and 3 are congruent and then swap them.
Yes, exactly right. That's what we're going to do. So what we're doing right now is you start planning your proof. You kind of go, okay, this is kind of the way I want this to go. Sometimes when you get to much longer ones, you'll just start and then you'll figure out where to go from there partway along the way. But on these that are fairly short, you really should be planning, all right, where am I going to go? So we'll start, like Marion said, by saying that angle 3 is congruent to angle 6. Why can I say that?
Alternate interior angle theorem.
Exactly right. The alternate interior angles theorem. Notice that my transversal there is crossing 2 parallel lines, so I know that 3 and 6 are congruent.
Are the stars supplementary?
Yeah, I've sort of adopted that.
I feel so special.
So now we can replace angle 3 in this original statement with angle 6. And we can say that angle 6 and angle 10 are supplementary. What is that called when you replace something with something of equal size?
Transitive property?
Substitution.
Substitution.
Transitive the equation.
Transitive is A equals B and B equals C, so A equals C.
And so that was just, this is swapped.
It's not swapping, it's making a list and linking it together.
I still don't really get why they're any different.
So we've talked about this, but no, it bears talking about again. You could say that this is substitution.
Substitution is
Rep-
transitive, but transitive isn't always substitution.
No.
No, other way around.
What? Transitive is substitution.
Transitive is a type of substitution.
But substitution isn't always transitive.
Correct.
Substitution's like the heading and then transitive subheading.
Sure. And honestly, so in some textbooks, they will only let you substitute into an equation. Like, it's got to have an equal sign in it. And so in some textbooks, and I think yours may even do this, on this problem, you would first have to say the measure of angle 3 plus the measure of angle 10 equals 180 by the definition of supplementary angles.
Oh, too much writing.
And then you would have to change 3 is congruent to 6 to the measure of angle 3 equals the measure of angle 6 by the definition of congruent angles, and then you could substitute.
Does the
That's
congruent
really-
symbol not count as an equal sign?
It's not an equal sign. But the longer I've taught, the more I'm like, that's just hoop jumping. I want people to understand the thinking process. And so I'm a bit more liberal about what I allow people to call substitution.
We're just gonna call everything substitution.
Yes, ma'am.
Do you have to stand all day?
I'm sorry?
Do you have to stand up all day? Like, don't you get tired of standing up?
No. I can stand up for literally, from the time I wake up until the time I go to sleep if I want.
Why?
How? I get tired.
I have 2 legs and they both work still. Yes.
Could you have done as like cited the could you have done like 10 and 11 are supplementary because of S and T are parallel?
Yes, you could.
And then gone from there?
Let's talk about that in just a second. Let's finish this, and then let's talk about that. Because there is a way to do it, we just haven't learned it yet. So now that 6 and 10 are known to be supplementary, I can conclude that Q is parallel to R. And that's because, again, anytime you're proving something parallel, that's the converse of something. In this case, the converse of the same side interior angles theorem. All right, so real quick, let's talk about Savannah's idea. And it's a good idea, but it involves a theorem that we haven't written down. But if you decide to learn it and want to use it, I'm happy for you to. So you said you were going to say that angle 10 and angle 11 are supplementary, right? So that would be fine. And that would be because of the same side interior angles theorem? The problem is, where do you go next?
To 11 and 3,
What about 11 and 3?
that they're congruent
And what reason would you give for that?
because like 3 and 10 are supplementary, and 10 and 11 are supplementary, then 11 and 3 have to be the same.
Right. So we need a theorem that says that. And so I'll show you that you can do it. And you're exactly right, and your thinking is spot on. You could say that angle 3 is congruent to angle 11 because what the theorem says, if 2 angles are supplements of the same angle, then they are congruent.
And then from there, you would just say that because of that Q and R, the converse of, the converse of corresponding in this postulate.
Exactly right. So then you could say that Q is parallel to R because of the converse of the corresponding angles postulate.
So we can use that.
Yes, absolutely.
What's that called?
Pardon?
What's that called?
What's what called?
Is there like a different name for it?
For which, who's it?
The
Oh, that theorem?
Yeah.
Some books call it the equal supplements theorem.
Would you just want us to write the whole thing out?
Yeah, it's not super long. Yeah, but that's the other way you can do one where you have supplementary. You do another one that's supplementary to the one they have in common, and then those other two, just like you said, have to be congruent to each other. Yep, good thinking. All right. Let's do one that has some interesting things in it. I'm going to do this as a 2-column.
Yes.
You with us?
Yes.
Really? I've already written down statements and reasons.
Oh, well.
You've drawn pretty pictures.
Yeah, but they're not pretty.
No. I just am switching it up. If you want to do a flow chart, that's fine. So we start off with angle 1, way up here in this corner, is congruent to angle RIS.
Are they alternate exterior angles?
No.
The same side exterior angles?
Nope. Nothing.
Why not?
They're not on the same transversal. Well, they are, but I guess, let's see, what would they be? Yeah, they'd be same side exterior, but it's kind of weird.
Okay.
But yeah, they are same side exterior. All right, so with this one, we've got an angle bisector. We haven't done much with angle bisectors in a while. What is it that an angle bisector does?
We split the angle into two equal and
Not equal,
congruent
two congruent, pardon?
angles.
Yes, it splits the one angle into two congruent angles. Anytime you have a word that you know the definition of as part of the given, you should immediately use that definition to make a new statement. So we know that a bisector divides one angle into two congruent angles. So if we're dividing RIY into two congruent angles, those two congruent angles are angle RIS
And SIY?
and angle SIY. And that's because of the definition of an angle bisector. So anytime you have a definition word given to you as part of the given, your next thing should just immediately be use the definition to make a new conclusion. So we've got these two angles are congruent. Well, notice what we have. Angle 1 is congruent to RIS, and RIS is congruent to SIY, so exactly, angle 1 is congruent to angle SIY. That's the transitive property. And then what kind of angles are SIY and angle 1?
Alternate exterior angles?
Yep, they're alternate exterior angles. And when alternate exterior angles are congruent, what do we know?
The lines are parallel.
The lines have got to be parallel. So here's our transversal for those two. And here are the two lines. Oh, look, TI
TI?
and DN.
Stop.
So TI is parallel to DN. Because, again, when you're proving lines parallel, Savannah, you have a perplexed look.
I don't understand how we got
Oh, we had one's congruent to RIS, and in turn, RIS is congruent to SIY. So we've made a chain of things. This is congruent to this, and that same thing is congruent to that. So the first and the last have to be equal to each other.
But how does that?
Oh, how do you get to step 4? Sorry, I thought you were saying you didn't understand how we got to step 3. My fault. So SIY and angle 1, here's the transversal. The other side of 1 is this line. The other side of SIY is this line.
So they're alternate to you.
Exactly. So this is the converse of the alternate exterior angles theorem.
Mr. Davis.
Sir,
So when you're proving that the lines are parallel, is it always going to be a converse of the
yes it is.
theorem?
Yeah, when you're proving that lines are parallel, it's always going to be converse of one of our postulates or theorems. All right, last one. Oh, yeah. Sorry, not last proof, just some more practice.
Oh, is this what we did on the homework?
Yes. So let's see how you're doing. If 2 is congruent to 7,
QRGS,
why?
because
Other lines.
they showed the transversal QS, and so it's the other line that makes the angle 2 and 7.
So what kind of angles are 2 and 7? Alternate interior. So this is an example of the converse of the alternate interior angles theorem. Pardon? No, it didn't ask for it. So if 1's congruent to 8, then which 2 lines are parallel, if any?
QT and R.
Yeah, QT is parallel to RS. Again, that's the alternate interior angles theorem converse. All right, if 4 is congruent to 6,
It's not,
it's not.
because they're supplementary, right?
4 and 6? No, 4 and 6 are not supplementary.
I thought same side interior angles were supplementary.
If the lines that form them are parallel.
Therefore,
The lines that form those are very obviously not parallel, though, right?
I thought it was just one line that formed it. With TR. Oh.
Since the lines that form those angles make a triangle, there's clearly not any lines that are parallel. So it's absolutely possible for same-side interior angles to be congruent. But if they are, we don't know that any lines are parallel. Nice catch.
The 3's still going to be none?
Yeah.
Okay. Wrong formula, right answer.
It's like I had a student years ago who, I think it was in pre-algebra. Oh yeah, I said, solve this using a system of equations, and instead they wrote out a table and just kept going until the 2 matched and said, this is my answer. And I'm like, well, yes, that's the right answer, but you didn't do what I asked. And that student's parents were unhappy with me. He got the right answer. I was like, yes, I know. It's a little bit like playing baseball and going from home to third to second to first back to home. I made it all the way around the bases. What's the problem? The problem is there are certain rules. All right. No one really cared about that story, did they? All right. Angle.
Is that what you're gonna say in the future? Like, I used to have a student who is like, isn't that weird?
Like drew pictures on her paper all the time. Yeah, I'll tell that story.
I assumed
Everything that you do is potentially a story for future classes.
It's a bird.
Yes, it is.
to tell your students that I started the IRC Davis.
Okay. So angle QTS is this angle, and angle TSR, this angle over here. What type of angles are those?
Same side.
Same side interior is supplementary to the right relationship?
Mm-hmm.
Yep, so which lines are parallel?
QT and RS.
Yep, QT is parallel to RS. This is one of those ones where you really want to use a pencil and have a good eraser. So QRS is this angle over here. TSR, this angle down here.
They also same side interior?
They are also same side interior. Is supplementary of the right relationship?
Yeah.
Yep. So the line that they share, RS, is the transversal. The other two sides, QR and TS, will be the two parallel lines.
This is the first lesson that actually made sense.
That you actually what?
That actually made sense.
Wait.
I don't know if that makes me worry more about me or you. Yes.
So, if there's some, are same side interior angles always supplementary?
No.
So how are they supplementary? Like, because he said not to assume that the lines are parallel.
Correct. I'm telling you that the angles are supplementary. And we're concluding
Oh,
that
okay.
because those angles are supplementary, the lines have to be parallel. Okay? All right, then QTS, that's this angle down here. And QRS, these two angles are supplementary. What kind of angles are those?
Exterior.
They aren't any kind of angles.
Oh,
Yeah,
that was
Jay.
a question. That was a terrible question.
Also,
Yeah, none is always a possibility. Okay?
Sometimes possibility's bad.
Yeah, man, every time someone asks me some questions in here today, I feel like responding with something rude.